Hi everyone, I'm here to talk about how math educators think about story problems. Most adults are probably used to thinking in terms of addition or subtraction problems, but it turns out it's a bit more complicated. The ideas I'm sharing in this video are based on arguably one of the most famous bodies of work in math education, called cognitively guided instruction, and everything I'm sharing here is based on this work. And on a personal note, my first and second grade teacher, the brilliant Mathy Jenkins, taught me and my classmates math using these ideas, and then later in graduate school she taught me all about this work, and that's kind of how I ended up where I am today. So one of the things I like to do when I'm teaching my future teachers is to ask them which two problems are the most alike and why. And again, this comes from that body of work. So one question or one story problem we might ask is Mathy Matt has 8 calculators. He buys 5 more calculators. How many does he have now? Mathy Matt has 13 calculators. He gives 5 calculators away. How many does he have now? Mathy Matt has 8 calculators. He buys some more calculators so that he has 13 altogether. How many did he buy? So if you want to pause and think a little bit to yourself about which two are the most alike and why, I invite you to do that. When I do this, I usually get all 3 possible answers, and of course there are ways all of them are alike and different. So one answer we often get is that the end is unknown for A and B. We know the beginning and the middle of the story, but we don't know is what happens at the end of the story. Another answer I get a lot is that we can think of both B and C as subtraction problems. In the first one I can do 13 minus 5, in the second one I can do 13 minus 8. And then finally, some people argue that they think of both A and C as adding situations or adding problems because we start with 8 calculators, we get 5 or some more, and we end up with 13. So I want to talk about this a little bit, these two different ways of looking at it, and in particular what that says about problem C. Because we've got problem C thought of as both a subtraction problem and as an adding situation. So I want to talk a little bit about what's going on there. So let's just recap the story. I have 8 calculators. I buy some more, which I'm not sure how many more yet. It's a big secret apparently. And then I end up with 13. And the question is how many I bought at the store. And you can see I am pumped about my calculators there. All right, so how do we solve this? How do we think about this problem? A lot of adults think of this as a subtraction or kind of as a takeaway situation. They know we end up with 13 calculators at the end. And so what they're going to do, and they know that we started with 8, so they're going to get rid of those 8. So they're going to pull away 3, 4, 5, 6, 7, those 8 calculators we don't need and push them off to the side. And then they just have to count these remaining calculators and see that we have 5 left, and that's their answer. And they sort of treated the problem as subtraction or taking away. But that's not really the story that happened, and most kids like to follow the story. Kids like to think chronologically and follow the order of things that happened. And so they're going to treat it more like an adding or what we might call a joining situation. So first thing that happened is I had 8 calculators. So they're going to count out 8 calculators or blocks or hash marks on a paper or something like that. And then the next thing that happened in the story is I got some more until I had 13. And so they're just going to keep counting, but they're going to keep a little separate pile. So they'll count up until they get to 13, 12, 13. And so now they know they reached the end of the story, and they have to figure out how many of these new blocks or hash marks or calculators they have, and so they'll just count these and find that they had added 5 new ones to the situation. So in terms of if we wanted to write a number sentence or an equation to sort of match the thinking that's going on here, the adults treated the problem as 13 and they took away 8 and they saw what was left over, whereas the children started with 8 and saw how much they had to add up until they got to 13, how many more they had to add on or to that pile till they got to 13. And that the child's approach matches the story, matches what happened in the story. Now, to be honest, these are some of the more straightforward types of problems, and I want to look quickly at a couple of ones that are a little bit more complicated in terms of how strategies can match the problem. So I like to think of the problems we just looked at as a movie because something happens over time. There's some kind of change in the story. So in this story we have Mathy Matt has 8 calculators. We can think of that as scene 1, or we like to call it the start of the problem. And then he buys 5 more calculators, and so that's the change. That's the thing that changed in the story. You can see my calculators just starting to come into frame. And then in the third scene, the question is how many do I have? And the end result, I have all 13 of my calculators together. Right? And I can make any of those frames in the story, any of those scenes in the film, be the unknown part of the story. And that's how we get some different types of story problems. But the thing that they share in common is that it does have the start, middle, and end, or start, change, and result. All right, so I want to talk about a different kind of problem, a problem that is, to me, is not a movie, but it's more of a picture. And there's, in this type of picture, there's two parts that make up a whole. So Mathy Matt has 8 calculators, 5 of them are red, and the rest are blue. How many blue calculators does he have? I think of this as a picture because nothing happens. No calculators join, none of them leave. They're just sort of sitting there. I have to do some work to figure out how many are behind that little cloud, but nothing actually happens in the story. And because of that, it's more ambiguous how we might think about this problem. Some kids might start with 8 and then take away 5 and see what's left. And some kids might start with 5 and sort of count up and get to 8. All right, I want to share a different kind of picture problem, which is a compare problem. So Mathy Matt has 5 red calculators and 3 blue calculators. It's a lot like the problem we just did, but the question is different. Instead of thinking them as 2 parts of a whole, I'm thinking them as 2 separate sets. And my question is, how many more red calculators does he have? So again, nothing happens in this story. We might call it a story without action if we wanted to use some of the CGI language. But I like to think of it as a picture. There's just these calculators sitting here and nothing happens or changes. So I've got my 5 red ones, my 3 blue ones, and what I'm looking at is that sort of gap in between. And again, because nothing happens, it makes it more ambiguous and kids might approach it in different ways. And I will say the fact that this one and the one before it are ambiguous do make them a little harder for kids. So some kids might think of the 3 and building up to 5, or we might kind of think of the 5 and pulling away the 3. The most common strategy for this really is just to lay out the blocks or whatever tool you're using and side by side like this and then count the extra ones. All right, so what's the point of this? I just want to highlight a few big ideas. One is that most story problems are not they're not simply addition or subtraction problems. Instead, young children's strategies are going to depend more on the structure of the story and not how we might want to think about them as or try to classify them as adults. Another big takeaway from this body of work is that children can learn their math facts by using their natural strategies, just working on these problems from the beginning. So in other words, they don't have to memorize a bunch of math facts before they can start. They should just jump into solving problems like this, assuming that they know how to count and can listen to the stories. And then finally, there are similar ideas that come up with multiplication and division, and I may or may not make a video about that at some point. So anyway, that's my quick recap on how we think about story problems, or at least addition and subtraction situations with young children. Please send me your math questions about this video or anything else at mathymattfk@gmail.com or leave a comment on this video. And don't forget to like and subscribe.
Math's not a problem with Mathy Matt.